Am I audible in the back? Yeah, appear to be. So, good afternoon. What were we doing in the last class? Force fit game. तुषार के चेहरे पे तो स्मग स्माइल है ना, कुछ कह रही है. हाँ, क्या सॉरी? We just started the trizz. Okay. बट उससे पहले आदित्य बताएगा इसमें कौन कौन से आइडियाज दिए थे. So, see, what we did in the last class was this very interesting brainstorming method, which is called force fit. It's a game. We had completely gamified the idea generation process, and we enjoyed it. अभी भी उसके वो लिफ्ट में उतर रहे थे तो उसके 0.5 मार्क्स याद करके खुश हो रहा था. उसके मन में लड्डू फूट रहे थे कि मैं बच गया. हाँ. तो एलवीएस नाम कहाँ से चुना तुम लोगों ने भगवान. मतलब तुम तो सोते में भी एलवीएस और डीआरसी ही सोचते होगे, पता नहीं क्या है. So, but now that we are out of that, if we want to synthesize what happened in that game, actually, उस समय तो हमने इन लोगों की लगा दी. लेकिन now come to think of it, जब हिंट दिया गया फिश का, इन्होंने क्या कहा, फिश जाएगी और वो खा जाएगी और कुछ कुछ कर देगी. That was a funny thing. नहीं मिला उस समय मार्क. बट वो गेम खत्म हो गई. But does the creativity session end there? No. Whenever we, हमने बहुत सारे टूल्स देखे हैं अभी तक. थिंक लाइक समवन एल्स में रोल स्टॉर्मिंग, थिंक सुपर हीरो, उससे पहले ट्रिगर सेशन, उससे पहले 635 फोर्स फिट. we've seen multiple things. उस समय हम जो भी करते हैं, that is just a seed. Now I was just thinking about कि अच्छा, मतलब उस क्या हमारे को कोई भी सॉल्यूशन नहीं मिला. This was a thought that was crossing my mind कि क्या हमें कोई भी सॉल्यूशन नहीं मिला. एंड आई वाज थिंकिंग कि जो क्लू था फिश वाला, जिसके ऊपर हम खूब हंसे थे कि वो हवा में फिश उड़ेगी अब. हाँ, actually it was such a powerful clue. Now you did not connect it the right way, that is a different thing. But come to think of it, fishes are used in pedicure. What happens in pedicure? Lots of small fishes come, they eat some dust, something from your feet. किस किसने कराया फिश बेस्ड पेडिक्योर? खड़े हो, सबको दिखाओ अपनी शक्ल. नहीं, शक्ल पे नहीं करवाया था, हम दिखाना चाहते हैं कि यहाँ पे भी एक नमूना है. That's joking. So, what do the fish do? They just come and they nibble. And in the process, they take away unwanted stuff. What was the problem we were working on? Removing weeds. Unwanted stuff. A swarm of fishes come, they nibble. What could have been a solution? Okay, just like a swarm of fishes come, we'll have not one robot, but multiple little drones, robots, machines, which would go, they will sense that, oh, this is a weed. And one of them cannot remove it, but multiple of them together will kill it. This connection leads to a very feasible solution. Now, let me stretch it a little more. What do fish otherwise do in farms only? In other farms, when fishes are put, for example, alongside paddy, fishes ka jo excreta hai, that acts as manure, that enriches the soil. Am I right? So, what could our fishes do now? Now you connect. What could our fishes do now? They could, whichever weed they are removing, weed is organic matter, they could shred it and leave it there. That organic matter, what will happen? Earthworms will eat it. They will convert it into manure. And the weeds, which were otherwise negative for us, disposing them off would be a problem for us. Now that swarm of small fishes would be able to convert that into positive manure. Same clue. So far away from the stuff. The team could have connected it. I'm not saying they could not have. You did not, that's why you got just 0.5. Okay? But I'm just talking about the way solutions can emerge. You need to stretch yourself and then they will emerge. There was this other idea of earthen pots and something to keep the medicines cool. Again, we looked at क्या था उसके अंदर क्या जकात शब्द आया था जिसको हमने कनेक्ट करा था कि जकात की जगह हम थोड़ा सा पानी डालेंगे. So actually the clues themselves can be very powerful pointers to solutions. Now that is one aspect of it. कि हम उन प्रॉब्लम्स के भी सॉल्यूशंस अच्छे से निकाल सकते थे. नहीं निकाले, that was a different thing. But then later we sit again, we review every word. Now we are not in a competition against each other. Now we are together. We have this list of clues, we have these list of ideas. And now this is our brainstorming database. इसके ऊपर आप work करोगे और solutions निकालोगे. Are you with me? Does this make sense? Now, for all of us, clues are now being given by, whenever we go to a technical contradiction matrix, the clues are given by Altshuler himself. He has said, oh, this is your problem. These are the clues. Now work them out. Are you able to see this? Those are the clues. Now apply force fit. नमन को लग रहा है क्या फ्रेंच और ग्रीक बात कर रहे हैं. आ जाएगा. So in force fit game, what we did, what you do? We had a very big problem, and we received distant clues. Then उन clues के ऊपर हमने workout करा. So I know, and amongst us, we did not do as many clues or as many things. This is also coming from the previous batches recording that we had, and the previous batch, the clues that was given was how to handle air pollution, and someone said wet floor का जो sign होता है वो दिखा दो, locked door दिखा दो, ये दिखा दो. So they gave such clues, and the solutions that were like, okay, wet करने के लिए can I do artificial clouds? Yeah, cloud seeding and then have artificial rain there. Pollution traps inside the, so lock करने का मतलब pollution को गाड़ी में ही रोक दिया. Small traps inside the cars themselves ताकि pollution, vehicular pollution limit हो जाए. And things like that. Ant, किसी ने ant दिखाया तो ant को चलता walking track दिखा दिया. So lots of solutions. Some would work, some would not work. Maybe all will work in parallel, in tandem, complementarily. But it is a very powerful game. And fun game also. मजा तो आया था जब फिशेस को तुमने उड़ाया था. नहीं? So now today we will move to the problem identification and TRIZ. And the first method of problem identification that we will use is cause-effect chain analysis. When I was introducing it in the last class, I had likened this method to some common tools that are used. Which were they? What are the common? मैंने कुछ fishbone diagram and 5 whys. So those are standard tools, five eyes and fishbone diagrams, that are used in organizations to identify what failed, what is not working. So in five eyes, what do? You start to ask the question why. Why did it not work? There will be some answer. Okay, why did that happen? There will be some answer. Why did that happen? So the five, it is called five whys because you have to go to at least a depth of five. Okay. Fishbone diagram is also like that. And fishbone, how many of you have seen fishbone diagrams? No one has seen. Just one person has seen. पिछली बार की introduction के बाद भी you didn't want to check out what a fishbone diagram is. Five whys किस किसने सुना हुआ है पहले? Okay. So a fishbone diagram is something like this. So this is the event, and you start to go backwards. What happened when? So detectives, for example, would use fishbone diagrams very often to see what happened when. Then you identify, oh, this could have been a cause of failure, that could have been a cause of failure. This is not about asking whys. This is about asking what happened, what happened before, or when did that happen, when did that happen, when did that happen. So both of them have some limitations. They are both powerful tools because they put a lot of facts on the table in front of you. They are like mind maps. अगर आपने XMind का टूल डाउनलोड कर लिया है तो उसके अंदर माइंड फिशबोन डायग्राम्स इज वन ऑफ द फॉर्मेट्स इन व्हिच यू कैन do some brainstorming, because what they do is they organize a lot of otherwise available information in a structure, because now once things are in a structure, your brain can easily understand it, grasp it, and offer solutions around it. But both fishbone diagrams and five whys have some limitations around them. The cause effect chain analysis kind of takes care of those limitations and is therefore more powerful than these two schemes. Okay. We'll continue to ask the question why, and we'll also ask when and merge them. And the when thing is important because in there, we also talk about this happens only when that is there. So, and conditions. At this and this, when both the conditions come together, then the outcome comes like that. Or condition. Either this happens or that happens. The outcome will be like that, which is not there in five whys, which is also not there in fishbone diagrams. They are just putting stuff there, but in cause effect chain analysis, we also put logical operators. And you will see the advantage of it in just a little while. Okay? It's very important. So cause effect chain analysis is an analytical tool. Now I'm actually reading it because this is the way the definitions are. Okay. It's an analytical tool that identifies key disadvantages. Key disadvantages is a keyword of the analyzed engineering system. Engineering system is another keyword. So what if I use the term engineering system with you? What do you understand? We have not used this term until now in the class. But if I use the term engineering system, what do you understand? Okay, he's saying that system on which we are working. That is one way to look at it. What else? सब लोग तो वही नहीं सोच रहे होंगे ना, आप लोग कुछ और भी सोचोगे अगर मैं इंजीनियरिंग सिस्टम शब्द का प्रयोग करूंगा तो. A well defined constrained system. Okay. Which can reconfigured or optimized or controlled regarding the way that in such a way that we can solve a particular problem, like a type of system which can be reconfigured or controlled so that we can solve a problem in that. Okay. That helps to reduce human effort. Oh, he's come to the definition of a machine. Machine is any contrivance that reduces human effort. Good. Anything made by engineers can be called as engineering system. Step-by-step flow is defined. Anything made by humans, okay? Systems which are designed to make our life easier. Is your heart an engineering system? Did a human being make it? No. Driving anything. So I would actually want to go with the more basic definition over here, that the system on which we want to work on, where we want to solve a problem. Agritech, we said weeds hai, weeds hatane hai. That was, so that engineering system includes weeds, which are living organisms, includes plants, which are living organisms, includes furrows, जिसके अंदर आप चलते हो या रोवर चलता है जिसके ऊपर वीड्स उग जाते हैं, includes rodents, जो आके वहां पे वीड्स के साथ डांस वूंस करते हैं, मूवीज में तो कर लेते हैं. So all that is a part of your engineering system, because that is where you want an engineering solution. Heart becomes an engineering system when you want to design a pacemaker around it. Is it not? Or when you have to put a valve in it, because some functionality there has gotten damaged. So anything where you can apply an engineering solution, or where you want to find an engineering solution, can be considered as an engineering system. Is that okay? It is not necessary कि किसी human being ने बनाया हो या कुछ ना करा हो. आपका intent है वहां पे एक solution निकालने का. That's an engineering system. It includes a lot of things: organic, inorganic, and events. Okay. Now, key disadvantage. Disadvantage to suna tha. What do you mean by key disadvantage? This is the very important definition with respect to. चलो next sentence पढ़ते हैं तो key disadvantage के बारे में शायद ज्यादा clarity हो आएगी. This is accomplished by building cause-effect chains of disadvantages that link the initial disadvantage to its fundamental causes. Now, what is key disadvantage? Main failure. So, my heart stops. Main failure is heart stopped. Is that what you mean? It would be like before the system fails completely. Okay, heart is not stopped. It's already I'm heaving. As I climb up and down the stairs, I'm heaving. So that is the thing. Yeah, that's why we do that bypass. Like if there is a fundamental problem that leads to a cause of the problem, then the fundamental problem. So utilize what I have just said before we started to open the slide. What did I say? What were the other techniques that I talked about? Use that language or merge that with the definitions that have been put here. What were we talking about? Fishbone diagrams, 5 eyes. Here we're talking about initial disadvantage and the fundamental causes and then key disadvantages. I'm just playing with you. Kuch bhi tukka to maro. See, if you would know all this, why would you do a course with me? If, in fact, this even ChatGPT can't tell you. This is so specific terminology, and there are not many videos or nothing much on YouTube or on the internet about all these techniques. तो ChatGPT के पास भी कुछ खास होगा नहीं ये बताने के लिए. तो यहाँ पे आपको खुद अपना दिमाग लगाना है. What would it be? Then what is initial disadvantage? Just like you said, your heart stop beating, like clotting is the key disadvantage, which leads to other disadvantages such as heart pain or blood irregular. Okay, so what you are saying is key disadvantage points me to the cause of the initial disadvantage. So initial disadvantage is the symptom, is the cause of concern. For example, weedicide wale case mein, there are these weeds. That is an initial disadvantage. Now, or the weeds need to be removed. That is the initial disadvantage. And the cause, why the weeds happened in the first place. Suppose I say weeds happened because I overwatered. This point came last time. Rohit ne bataya tha. If you overwater, then there is more resource available and weeds would grow. If you would not overwater, then the weed growth will be stunted. So one of the causes of weed growth is, my problem is, initial disadvantage is, I want an engineering system that removes the weeds. Why remove the weeds? Because weeds have grown. Why have weeds grown? Because more water is there. Why is more water there? Because flood irrigation is done. Why is flood irrigation done? Because it's convenient. Okay. So somewhere labor, effort, and water usage are figuring in. So what is the key disadvantage? Convenience of or low cost of flood irrigation. Now, to remove weeds, if I handle that flood irrigation problem, now do I need that robot that cuts and nibbles? So if I now, and suppose if for me, drip irrigation is very simple, the solution is very well known. If I know that I can do drip irrigation, then do I need that solution of machines in the first place? I don't know which one is cheaper. But if I can do an analysis, drip irrigation, everything is readily available. Pipe hi khareedne hai, nothing else is needed. Is it not? Now, the challenge is that the only reason of weeds? No. So I can do drip irrigation, it will solve only partial problem. There could be something else also. Is it not? So there can be more than one reasons why weeds happen or why an engineering system is required. And to solve the problem, you may want to solve those 10 smaller problems than one bigger problem. It may be far more effective in terms of cost, time, energy, resources, every way. Is it not? Imagine you're making a robot with 10 hands, which all the hands go and act like fishes. It's a complex robot. चूहा आएगा वो भी उसको खा जाएगा, वो चूहा है उसको टॉपल कर सकता है, उसकी स्टेबिलिटी देखनी पड़ेगी, रोबोट के अंदर कितना सारा आपको कैलकुलेशंस लगाना पड़ेगा. Instead, identified the key disadvantage. Drip irrigation दिया, now the weeds है ही नहीं. Problem solved. Are you able to see this? So अभी हम solve करने पे नहीं आए हैं. We are still in the stage of identifying the problem. Which problem do we want to solve? That is what we are looking at over here. So we will do function analysis and flow analysis later. Okay, but disadvantages are like problems that we see. Altogether, I use the term disadvantages for them. Okay, and many of the problems that we see are caused by just a few key disadvantages. If we can solve those preceding disadvantages, preceding problems, flood irrigation हटा दिया, तो the initial disadvantages are eliminated. And the ultimate goal of this analysis is to identify which problem to solve. क्योंकि so Professor Vishweshwaran को कौन-कौन जानता है? Oh, very few. So Professor Vishweshwaran was a visiting faculty here and he used to teach courses. In लोगों के साथ, he might have taken the basic no course. Okay. So he was, by the way, also my PhD guide. Okay. And he used to say, or he still says this one very interesting thing, that good engineers are lazy engineers. अब सब कहेंगे, chat GPT जिंदाबाद. No. Good engineers don't use chat GPT. They are lazy without using chat GPT. Okay. So what he meant with that was, or what he means with that is, they want to avoid a lot of work. They want to come up with simple, elegant solutions. See, complexity के साथ तो कोई भी problems को solve कर देगा. You can make very, very complex solutions. But elegant solutions have their own beauty. And good engineers come up with elegant solutions. That is what he meant by a good engineer is a lazy engineer. To become a lazy engineer, you have to be very, very, very sharp. You have to be very astute in identifying which problem to solve. Because if you solve big problems at the way they are appearing in front of you, there will be so many corner cases that you will make the solution very, very complex. So those of you who are in the IPDCP program, I'm taking this Leading Self to Excellence series in that program. And in this, one of the statements that Steve Jobs says is that, you know, for thousands striking on the leaves, अगर मेरे को कोई पेड़ को काटना है, so I can do 1,000 strikes on the branches and the leaves, but one strike on the roots is stronger than that. Okay, so we can solve the canopy of the problem. भयंकर बहुत सारी problems दिख रही हैं, हम एक एक को करके solve कर सकते हैं, which many engineers do, by the way. But good engineers go deeper. They want to identify why is this problem coming, and they act on the root. That is what cause-effect chain analysis helps us to do. Are you able to see this? That's the potency of this method, identifying, because मैंने शायद ये बात mention करी थी पहले, that Albert Einstein was asked once that, okay, if you give you, or he said once that if you give me 1 hour to solve a problem, I will spend 55 minutes analyzing it and 5 minutes to solve it. So this is that part. Which problem to solve? As I find the right problem, the solution will come like this. Otherwise, it's a humongous thing I may not be able to solve. So cause-effect chain analysis helps us in that. So what we do, we look at initial disadvantages, and then we start to go why this happens. So this is like uncovering, okay, why does this problem come? This problem comes because this happens. Why does that happen? Oh, because this happened. Why does that happen? Because this happens. Why does that happen? So what happens is the disadvantage is obvious to you. That was why the problem was assigned to you. When you start to ask the whys, you start to go into the hidden domain and they start to become evident. You uncover, you unpeel, अनियन को जैसे आप एक एक लेयर करके हटाते हो. And जो key disadvantage कहा गया है, it is those disadvantages which are either given as specification by the user. Now, okay, specification by the user में नहीं कहूँगा, which are non-negotiable requirement from the system. That you simply can't change that. Okay, some law of physics, some material property or something, that this is what it is. That doesn't mean that you can't, they cannot simply be changed, but at least you identify, oh, all this happened because the user asked for this. Now, if I talk to the user and check with them how important this feature is for them, and if it is not important, I will remove the feature and the problem is gone. Nothing else needed. Just design thinking, empathy, interacting with the user, understanding what they really need. They might have said something, but they did not mean it like that, as we have understood it. It might just be a problem of translating user's language into my language, as I understood as an engineer. Possible, na? Possible? So the key disadvantages, even if they are like user specifications or physics or something, we can see how to work around them. But working on the key disadvantages might be easier. Okay. Now, this is just a chain of disadvantages, just like a 5 whys would do. Until now, what I've shown you is what the 5 whys also does. This is where it gets converted to cause-effect chain analysis, where we put operators like or and in the picture. So now suppose I have this initial disadvantage. I need to solve this. I have another initial disadvantage. So I have these two disadvantages, 1 and 5, and I want to solve them. Which is the most effective problem to work on? हाँ, जोर की key disadvantage 5. नहीं, where should I work on it? यहाँ पे इतने सारे blocks हैं, which one should I work on? ताकि initial disadvantage 1 and initial disadvantage 5 दोनों solve हो जाए. 4, 8, 10. Okay. 4, 8 या फिर 4, 10. Okay. Sorry. 2 and 6. Or 4 and 10. Now, actually, अगर आप ध्यान से देखो, just be alert now. He's saying 4. तुम क्या कह रहे थे? 4. Okay. So, if I take care of disadvantage 2, both key disadvantage 1 and key disadvantage 5 are taken care of. Same for 3, same for 4. Are you able to see this? Do you now realize you have a choice? Which was not evident earlier. Earlier, it was an overwhelming situation. Key disadvantage 1 and key disadvantage 5. नहीं, initial disadvantage 1 and initial दो चीजें solve करनी है. And as soon as you made this cause effect chain analysis, you see, oh, actually, एक ही चीज solve करनी है, and वो भी कौन सी solve करनी है? I have a choice. Are you able to see this? Now, which one would you choose? Let us say that disadvantage 2 को solve करने में 1 man month का effort लगना है. Disadvantage 3 को solve करने में 15 days का लगना है, but आपको एक extra resource चाहिए. And disadvantage 4 को solve करने में 4 महीने लगने हैं. Which one will you solve? You will see whether that extra resource is readily available, what is the cost of that resource, and versus just 1 month there. And then, do you realize that the solution now becomes so different? So that is the potential of cause effect chain analysis. So how do you identify which one is the key disadvantage? A key disadvantage is one which, the underlying cause of the key disadvantage is either physical, chemical, biological, or geometrical fact, or I would also say user requirement, need, user को ये चाहिए. Again, you can go. इसको भी हम key disadvantage ना कह के actually जा सकते हैं, why does the user need it? If I can meet that need through some other means, the problem goes away. So you can still continue to ask whys, but some people stop at, okay, मेरे को तो user ने ये दिया है, ये specification मेरे को मिला है. So you go, then you need to go beyond just your engineering team, and you have to contact the customer relations team and understand why does this requirement come, or the marketing team, or someone else, user surveys. So you have to go out of the engineering room there. But key disadvantage otherwise would stop at only one of the physical, chemical, biological, geometrical, or some such fact, which is a fact which you can't change. Okay? And removing a key disadvantage removes most of the disadvantages in the cause effect chain. अगर मैंने वहां पे disadvantage 4 को solve कर दिया, which is the key disadvantage, तो भी सारे के सारे solve हो जाएंगे, नहीं? Everything will get solved, is it not? But मैं कह रहा हूं कि मेरे पास अब choice है, मैं 2 को भी कर सकता हूं, 3 को भी कर सकता हूं. Are you with me? Okay. So let us say someone had a headache. Now you go to a doctor. What does a doctor do? Test. आज सर बड़ा सिर दर्द हो रहा है, कभी कभी हो जाता है, क्या कहेगा? डॉक्टर के पास जाने से पहले ही तुम कहोगे यार सैरिडॉन खा लेता हूं. What have you worked on? Initial disadvantage. Problem is solved, but one day, आज जब हुआ तब, 3 दिन बाद फिर से होगा, 10 दिन बाद फिर से हो सकता है. Now, if you really want to nip it in the bud or solve it for good, you need to do some analysis. So a good doctor will not just give you Saridon. What they will ask you is a few set of questions. कि बीपी है क्या? हाँ, बीपी जब बढ़ता है तब होता है. ओके. अपना ब्लड टेस्ट कराओ. Let us measure the salt content. ओके, पता लगा सॉल्ट कंटेंट ज्यादा था, तो पता लगा रॉन्ग डाइट. सो नाउ अब सिर दर्द होता है का सॉल्यूशन इज नॉट सैरिडॉन, इट इज improvement in diet. And once you improve your diet, it is not just headache that you are solving, you're also solving BP and many other complications linked to it, is it not? अभी तो आप सिर दर्द लेके गए. A high BP can cause so many other ailments to you. नहीं, मैं आपको पिज्जा खाने से मना नहीं कर रहा हूं, जिसको पिज्जा पसंद है आप खा लेना, बट ये एक एग्जाम्पल है. स्विगी पे ऑर्डर करके खा सकते हो, या तुम उसके हाथ से खाना चाहते हो, उसने मना कर दिया खिलाने से. हाँ, so that is the intent of arriving at key disadvantages. That when you handle a key disadvantage, you actually solve a lot of other problems that could be there in the system. ये पढ़ा जा रहा है आपसे? मैं पढ़ के बता देता हूं. So there are problems with the drilling machine, and there is an OR operator which says that this machine की problem जो है that could be because of the transmission breaks easily. It's not, yeah, मजा नहीं आया. The transmission breaks easily, or the electronics is unreliable, or the motor breaks easily. Why does the transmission break easily? Because either bearing breaks or gears break. Why does motor break easily? Because the load on the motor is too high or the motor is too weak. And as you go down, you may find that there are some key disadvantages which you can handle. And that will solve not just this final problem, but many other in between. For some problems, you may find a solution here that I will change the quality of my gears. For something else, you may find the solution somewhere else. Let us look at this. There are problems with the drilling machine. Average lifetime is 20K hours. It should be 40K hours. Why does it happen? The transmission breaks easily or motor breaks easily. Now, to solve this problem, you have to handle problem 1 and problem 2 both, because there is an OR operator. And then transmission क्यों break कर रहा है? Because bearings break easily. Average lifetime is 25K hours, should be 40K hours. Gears break easily. Average lifetime should be 30K hours, should be 40K hours. Again, यहाँ पे और है. Both have to be solved. Are you able to see this? So now I would want you to do an exercise. Please bring out your notebooks. Form groups of 2 people, at most 3 people. आदित्य ने, मैंने पूरा भी नहीं कहा, 3. Form groups of 2 or 3 people. And I told you that you must be working on some projects, some problems you are solving in your curriculum over here. Pick up any one of those problems, share the problem with each other, pick up any one of those which you think is interesting, and try to solve or build the cause effect chain analysis. Now, this works best when you are working on a problem where all of you understand the problem well. So either you choose groups so that you can pick up your technical problem, or if you are forming groups where you cannot really pick up the technical problem, then pick up the generic problem like हमने जो उस दिन बात करी थी, we want to keep the medicine cool without using electricity, or something like that, because or the other problem was how to remove weeds from a farm. You can pick up either of those two problems, or you can pick up any other problem that you think your other team members understand and can work with you on that. Is that okay? So please, quickly. What I want you to do is build something like this, where you have a initial disadvantage, so a set of initial disadvantages. You first do the 5 why analysis, list down all the reasons, and then connect them with the operators. That becomes your cause effect chain analysis. Is that okay? Any questions? You first do the 5 why kind of analysis, and then you add the operators in there, and that becomes your cause effect chain analysis. Discuss amongst yourself. Teams banao quickly. We have how much time? 20 minutes. One problem statement, analyze it in 20 minutes. Quickly. क्या प्रॉब्लम ढूंढा? कुछ भी, तीनों को मेमोरी आती है ना, तो कोई प्रॉब्लम नहीं है. दैट इज नॉट अ प्रॉब्लम. व्हिच प्रॉब्लम डू यू वांट टू सॉल्व? That is not an okay. Find some. This is an operational thing. Find something which is like अगर memory design करने के कर रहे हो तो okay, how do I make the memory cell less leaky? Find something which is meatier, not a logistics problem. वो भी कर सकते हो, but जब बैठे ही हो साथ तो कुछ अच्छा ढूंढो. क्या एग्री करा? Solution नहीं पता की बात नहीं. You should understand the problem. You should understand the engineering system. If you do not understand the engineering system well, you can go to a common problem. As of now, in this class, I'm not expecting you to find a solution. In this class, I'm expecting you to learn the method. Okay? In this class, I'm asking you to understand the method. I'm not interested in the solution that you come up with. प्रॉब्लम लिखो. ये प्रॉब्लम नहीं है. हाँ. क्या प्रॉब्लम है? सोचो. क्या निकाला है? पेस्टिसाइड नहीं डालना है. अच्छा. ओके. ठीक है. घबरा क्यों?
Students, when they go to sports block, they're disappointed because they don't find an enrollment. So that is caused by not knowing.
Okay, वो cause of it करना, but problem is that students are inconvenienced when they go to the sports field. All of you are sports persons. You know what the situation is. Okay. Op- operators बाद में डालो. So first of all, do the 5 why analysis. List down all the possible reasons. Then put the operators in between them. Okay? क्या प्रॉब्लम निकाला आपने? Okay. Growing नहीं removal. Weeds are always unwanted. The problem is you want to remove the weeds. Hmm. At the lowest cost. So, identify what is the problem. हटा तो दोगे ही. What do you want to reduce? Mhm. प्रॉब्लम क्या है? The problem should sound like the the tool or the training for learning Excel should cost 10 rupees. It is costing 2000 rupees. Now you see what has happened. Are you getting it? तो जो आपको टारगेट है सॉल्यूशन का वो भी रखो साथ में. यहाँ पे हमने क्या दिखाया था? The drilling machine should work for 40,000 hours. It works for only 25,000 hours. And then we go drill down. So you guys also, you can say that, okay, the problem is that I should, whenever I go to the court, the wait time should be 0. Today, the wait time is 5 hours. Now you see why is the wait time more. Okay. You should have a target also when you're defining the problem that you want to do the cause effect chain analysis for. Objective होना चाहिए आपके माइंड में कुछ. Sir, problem of AI Inventive. What does this mean? This is so vague. Education is implementing AI on all these. No. So आप इसको ऐसे जैसे उधर पढ़ो ना, वहां पे क्या लिखा है कि I want the life of the drilling machine to be 40k hours. It is only 2k hours. तो आप ये लिखो I want students to do their assignments themselves, but they are using AI. You're getting that? Then you will do the cause effect chain analysis, which will help you solve the problem. ना टारगेट साथ में रखो, नहीं तो बहुत वेग रहेगा. जो भी कीप द नंबर, जितना न्यूमेरिकल कर दोगे उतना आसान होगा तुम्हारे लिए हार्ड हो जाएगा. अदरवाइज ऐसी हवा में बातें होती रहेंगी. हाँ जी. तो नंबर डालो. तो नंबर डालो. In India, per hectare yield of wheat is 50 kilograms or 50 tons. In the US, it is 1000 tons. तो फिर वो प्रॉब्लम मत लो. ऐसी प्रॉब्लम लो जो तुम समझते हो, या फिर हाँ सर्च करो जो भी है. But see, if you do not understand the real problem, how will you do the cause effect chain analysis? You're not experts yet. Pick a problem which is closer to you today. Now, you may become an expert in this after 2 months of study. But अभी है क्या? अभी मत करो वो. अभी pick up something that you do understand a little bit more than this. Okay? And clearly state, this is my goal, this is where I am. Why is this gap there? Okay? क्या निकाला? तो इधर लिखो power is 1x, I want to go to 0.5x. Why is power 1x? It should be 0.5x. So power is 1x, it should be 0.5x. Now look at why is this power 1x. Then you will arrive at key disadvantages on which you could work to make this power 0.5x. सबसे पहले 5 why technique लगाओ, list down all the possible reasons, then put the operators between them. Okay? So, no, wait. Favorite students should get 90 marks. They are getting 50 marks. Why? कि otherwise, whatever, हवा में शेखियां मारते रहोगे, solution नहीं आएगा. Then the real problem. यही है ना, मेहनत करी, सोच रहे थे 90 आएंगे, एग्जाम आया 50 आ रहे हैं, क्या हो गया? हाँ, पहले 5 वाइज की तरह करो, फिर और एंड ऑपरेटर्स बाद में लगाओ, ठीक है? ऐसे मत करो, तो ऐसे में तुम फैल जाओगे हर तरफ. तुम लिखो PM 2.5 count should be 100. It is 300. है ना? What is the problem? PM 2.5 का जो काउंट है, AQI जो है, that is 300. It should be 100. तो वो फिर फैल जाएगा ना सब कुछ. एक प्रॉब्लम उठाओ, कोई एक उठाओ, या साउंड का उठा लो, कुछ भी उठा लो. The noise, the sound level, ambient sound level should be 1 decibels. It is 80 decibels. Quantify करो थोड़ा सा. Then you will be able to do a better analysis. No, the problem should be the drone should be able to fly for 4 hours. It is able to drive only 1 hour. तो फिर नहीं, तो फिर ये सारे आपके इनिशियल डिसएडवांटेज हैं कि साइज ऑफ द ड्रोन इज अ डिसएडवांटेज. तो फिर साइज शुड बी 1 feet. इट इज प्रेजेंटली 5 feet. फिर उसको सॉल्व करो. जो भी प्रॉब्लम स्टेटमेंट ले रहे हो उसको क्वांटिफाई करो. Then when you work on it, you will be able to arrive at better wise. Problems will be simpler enough to handle. Otherwise, फिर वही बड़ा सा कुछ रह जाएगा. रिजल्ट की बात नहीं कर रहे, but at least problems which are more manageable. प्रॉब्लम क्या उठाया? चलो पहले बताओ प्रॉब्लम क्या उठाया. ओके, सो प्रॉब्लम होना चाहिए 100% trains should arrive on time. 85% trains arrive on time. What are the reasons? Now ask why. Put the number. Delayed locomotives doesn't matter. ऐसा नहीं है, तुम जो ही कहोगे ना, अच्छा चलो अगर तुमने इसको न्यूमेरिकली करा तो क्या होगा? ओके, 100% of trains should be arriving on time, 85% is arriving on time. Why are the 15% not arriving on time? Now there can be multiple reasons. यहीं पे आपका एक फ्लावर बन जाएगा. किसी को फॉग मिला, वेदर कंडीशंस थे, किसी ने स्टॉप कर लिया, किसी ने कुछ कर लिया, किसी ने कुछ कर लिया, किसी ने कुछ कर लिया. अब हर एक के नीचे तुम लैडर कर सकते हो. फॉग में ट्रेन क्यों नहीं चल पाई? क्योंकि फॉग लाइट अच्छी नहीं थी. हाँ, दूसरा क्यों बार बार रुकी? बिकॉज किसी ने चेन पुल करा. क्यों स्पीड नहीं पकड़ पाई? बिकॉज ट्रैक अच्छा नहीं था. मुझे नहीं पता. देन लैडर डाउन. ठीक है, बट स्टार्ट विद अ न्यूमेरिकल थिंग. जितना ऐसा वेग सा शुरू करोगे तो फिर मजा नहीं आएगा. जो ही तुम न्यूमेरिकल लेके जाओगे तो एकदम से अच्छा चीज निकलेगा. यही तरीका है, बट अभी तुमने इन सबको पैरेलल में कर दिया. तुम ये सारे एक्चुअली पैरेलल के वाई हैं. तो तुम्हें लगा 5 वाई पूछ लिया, हो गया काम खत्म. जबकि कॉज इफेक्ट चेन एनालिसिस में आप 5 अलग अलग ब्रांचेस आएंगे तो उसके अंदर आप पांचों में डीप जाओगे, तभी तो सॉल्यूशन निकलेगा. So you should start with AQI should be 100. It is 300. And then answer the questions why. अभी आपने यहाँ पे और एंड ऑपरेटर्स डालने की कोशिश करी है, बट आई वुड से थोड़ा सा नीटली बना लो ताकि हाँ सो मैं सबको ये कह रहा हूँ कि ब्रिंग इन अ न्यूमेरिकल नंबर दैट द the DIMC should have 1 million tops per watt or 1000 tops per watt. Performance I have today is 20 tops per watt. Now ask the questions why. जब तक आप उसको क्वांटिफाई नहीं करोगे ना, हवा में चलती रहेगी बात, सॉल्यूशन नहीं निकलेगा. क्वांटिफाई करो, दैट इज द फर्स्ट थिंग. इनिशियल डिसएडवांटेज को क्वांटिफाई करना बहुत जरूरी है. ओके क्या निकाला? ओके क्वांटिफाई करो that presently Indian farms consume this much pesticide per ideal is zero pesticides. Okay, quantify जो ही करोगे then answers अलग तरह से निकलेंगे. Okay, क्यों नहीं कर रहे? तो मल्टीपल रीजन हो सकता है ना. So there is a concept called total cost of ownership. मैंने फ्लड इरिगेशन पे तो कुछ नहीं डाला, लेकिन हर सीजन में मैं अपने फील्ड्स में 30% ऑफ माय टोटल कॉस्ट को वीड्स को रिमूव करने के लिए डाल रहा हूँ. इफ आई से दैट मैंने 2 सीजन्स की या 2 क्रॉप्स की कॉस्ट को जोड़ दिया, क्या मेरा ड्रिप इरिगेशन उतने में हो जाएगा? So what probably is missing is we are not able to communicate the financial advantage of going to drip irrigation to the farmers. By using drip irrigation, you are reducing the effort of weedicide or weed removal by 90%. Now the proposition is very strong now. Instead of 20 people, you will now only hire 1 person to remove the weeds. So that is the way of recovering cost. So think of it like that. Put the numbers. बताओ कि weeds को रिमूव करने के लिए आज 5,000 रुपया पर एकड़ लगता है. फाइंड आउट, गूगल इन सबके पास है ना. 5,000 रुपया पर एकड़ लगता है. आई वांट दिस टू बी रिड्यूस टू 500 रुपया. Order of magnitude is good enough. Now say why 5,000 rupees? What is taking back 5,000 rupees away? Are you getting to see this? The moment you quantify, you will see that new solutions will emerge. New problems will emerge. They will start to become evident to you. If you do not quantify, तो हवा में बातें रहेंगी, तो फिर अटक जाओगे ऐसे. ठीक है? नंबर डालो, गूगल करके देखो को क्या कॉस्ट है, अपना टारगेट बताओ.
We're doing 2 parallelly to see what works best. One is people falling sick and Delhi pollution. One is
क्वांटिफाई करो, उधर भी क्वांटिफाई करो. That 20,000 people. Google just report कर, न्यूज रिपोर्ट को चेक कर लो ना. These many people quantified. टेक्निकल नहीं कह रहा हूँ, न्यूमेरिकल. एक टारगेट लाओ अपने सामने, जब तक टारगेट नहीं होगा सॉल्यूशन की तरफ नहीं पहुंच पाओगे। अब हमें बातें देती आएंगी, पॉलिसी डिसीजंस की बात करते रहोगे, टारगेट लाओ तो आंसर आएगा। पुट सम नंबर्स देयर। सर्किट डिजाइन कर रहे होते हैं तो ये कहते हैं ना कि एरिया इज 5x, आई वांट टू गो टू 1x। नंबर आता है तो सॉल्यूशंस निकलते हैं, नहीं तो एरिया रिड्यूस करना है, 5% एरिया रिड्यूस करके भी खुश हो जाओगे, 5% एरिया रिड्यूस कर दिया। जो ही 1x कहा तो 20, मतलब यू हैव कम टू 20% एरिया, 80% रिडक्शन पॉसिबल है। एटलीस्ट सॉल्यूशन तो ढूंढोगे उसके लिए, तो क्वांटिफाई करो, अदरवाइज यू विल कम अप विद इनइफेक्टिव सॉल्यूशंस। इतना सुंदर सा मत बनाओ, अभी ब्रेनस्टॉर्म करो, ट्रिगर लगाओ या कोई भी और स्कीम सी सारी थी ना लगाओ। क्या प्रॉब्लम क्या है? नंबर्स का है। अब इसके रीजन क्या है? बस 3 है। तो इसको अगेन आई वुड से ठीक है चलो करो जैसे तुम्हें कंफर्टेबल है। Why do we need energy to move from one place to another, to cook food? Why लिखो ना, उसके why के जवाब दो, हम तो हो जाएंगे। इतनी बड़ी प्रॉब्लम है तो फिर हम ये कहेंगे ओके विच कंपोनेंट कॉन्स्टिट्यूट्स मोस्ट ऑफ इट, तो हम उसके परसेंटेज पे जाएंगे, फिर उस बड़ी वाली मछली को मारेंगे। देखो तो सही।
हमने ऐसे बनाया जब आपने बताया कि प्रेफरेंट टाइम पे क्यों नहीं है, डिलेड है, फिर हम इसके लिए जब ब्रांच आउट करेंगे कि ट्रेन डिले और क्यों हो रही है, सर टाइम पे इनिशियली मैं आपको बताता
उसके बाद अंदर एंड और ऑपरेटर्स बाद में डालेंगे। करो नीट करो, उसको साफ सुथरा बनाओ। ठीक है फ्रेंड्स 20 मिनट्स हो गए, डू यू नीड मोर टाइम? हाउ मच? 5 minutes? 5 minutes sufficient? Please take 5 more minutes. लिखो irregular distribution of rain fed water, ऐसा कुछ। It's climate thing, it's a weather thing. नंबर आए yeah connect this to this all of them. So now you realize इसको सॉल्व करा तो कितना सारा और चेन सॉल्व हो जाएगा।
So I think
So, can we all turn around now? I want to cover something else also, please. So, if you, all of you have had a taste of what this method is. So, what did you find? Root cause of the problem. Okay. Like all of you worked on some problem that you knew, that you understood and to some level of depth at least. So, how many of you over here felt that just by doing this analysis, you understand the problem better and that there are already some solutions inside? How many of you felt that? Now just look around, see, almost all of you. Have we worked towards a solution yet? एक बार भी कुछ brainstorming करा भी हमने यहाँ पे? नहीं. All that we did was sat down patiently with the problem and tried to understand it better. Not alone. Alone कई बार बड़ा overwhelming लग सकता है. Groups of 2 or 3 people who understood the problem as well or as badly as you did, but you were now able to get better clarity of the overall situation. Now, for how many of you, the solution can be found at the initial problem itself? The initial problem itself is the solution. So you have to attack the initial problem itself. How many of you had that? Just one person. You also. Okay. 2 people. For how many of you, the problem that you want to attack is somewhere down there, or let me assume sabhi ke liye aisa tha. But now for how many of you, because you attack the problem somewhere down there, the overall problem is simpler and more manageable? Are you able to see this? That's the power of this method. What we will do next is actually more and more such methods to help us identify simpler problems to solve with the same outcome that you wanted. See, remember I asked you to quantify the outcome. He likho, numbers mein likho, numerically likho. So that you are clear, this is my answer. If something does not take me there, it is not the solution to my problem. Is it not? Quantification of the problem is extremely important. Otherwise, you will do all that fluff talk and the solution will always elude you. If you are really interested in finding a solution, the first step is quantify. Jaisa yahan pe likha tha that the machine should work for 40K hours, it is working only for 25K. So quantify. Then, as we just saw, almost all of you realized that solving some other problem than the initial problem was much simpler. For how many of you, solving one problem in the chain down below solved a large number of problems on the top. You see? A large number of initial disadvantages are handled by just few key disadvantages being attacked on. So now, the intent of doing this exercise for 20 minutes, 25 minutes over here was just to give you a taste of the potential of this method. Now you may go back, the real problem that you wanted to work on, you might not have even revealed it to your friends yet. Now go back to your workspace, desk, sit with the team members who you actually are working on that problem with, and apply the same method on those problems. कई बार क्या होगा कि आपके पास अभी यहाँ पे पूरी इंफॉर्मेशन नहीं थी. You did not have the required information in these 20 minutes. So now at least you know what are the gaps in your understanding. Do that survey, develop that understanding, then sit with this method again. But until you understand the problem better, you will only be, shooting arrows in the dark. It may work, it may not work. Are you now able to see that analogy that I had shown you earlier? That so many solutions, and you have to finding a good solution is like finding a needle in a haystack. But with TRIZ, directly move towards a most effective answer. Are you able to see the potential there? So what I would want you to do is we will assign we could create an assignment. You submit your work on the Google Classroom there. And we now go to the next method of problem identification. This is called function analysis. So just this phrase, function analysis, what do you understand from this phrase? What could it be about? I know you have no clue about what it is. You just saw that one chota sa image in that introduction to TRIZ wala video abhi tak, where I told you we did a function analysis and I showed you something. I know you don't remember it. So I'm not expecting you to remember it either. I'm asking you, if someone tells you I'm doing function analysis of a system, of an engineering system, again, engineering system ab constant rahega aage hamare discussions mein, okay? So if someone tells you I am doing function analysis of an engineering system, what would you understand from it? How the system works. I'm analyzing how the system works, okay?
To find the problems after understanding the functionality of
To find the problems after understanding the functionality of the system. So मतलब जो आप कह रहे हो, जो मैं उसका desired level of performance चाह रहा था, वो नहीं आ रहा है कि नहीं आ रहा है, that is functional analysis, okay? To study the limitations and capability of the systems, okay? Utility of the system, okay? So how many functions it can perform, okay? So सबसे पहले function analysis तो दो शब्द थे ना, एक शब्द क्या है? What do you understand by the term function? Working. Okay. So let us look at the formal definition of function analysis, and then let us look at how do we do it. So function analysis is an analytical tool that identifies functions, their characteristics, and the cost of the system and super system components. And I've shown this Swiss knife over here. Why a Swiss knife? It has so many functions in it. So what all functions does your system perform, or different parts of your system perform? How do they relate to each other? And what is the cost of enabling those functions at the system level and the super system level? Now, what is the super system thing? अभी तक तो हमने system engineering system की बात करी, अब super system क्या है भाई? हाँ? Abstract view, okay.
It's a measure of functions where this component can be used.
A system where this component can be used. This is my system. This engineering system is the, what do you call this engineering system? Water bottle. The super system is this. This bottle can exist without the table. This table is a part of its super system. This bottle can exist in vacuum also. Air is a part of super system. Huh? So, just give me a moment. So air is a part of super system. This bottle can exist without you. You are also a part of super system. But now, if the system is Prachi is drinking water from this bottle, then Prachi becomes a part of the system. Because now, can Prachi drink water without being a part of the problem? No, she's a part of that system. And what is the problem? The water spills all over the place. Okay? So an engineering system may involve, depending on how you are describing the problem, an engineering system may include some parts of the super system or exclude some of them. Are you able to see this? Now, the problem was that this bottle does not maintain the temperature of water inside it. Is Prachi involved? No. This bottle I just kept here. Prachi hai chahe nahi hai, it's not able to retain the water, the temperature. But जब spilling की बात आ रही थी, and Prachi was involved. तो डिपेंडिंग बॉटल, हम बात बॉटल की कर रहे हैं, हम शायद चेंज भी खाली बॉटल को ही करेंगे. एक सिस्टम में प्राची थी, दूसरे सिस्टम में प्राची वाज नॉट देयर. सो आपके लिए किसी भी फंक्शन एनालिसिस में किस चीज को आप सिस्टम में मानोगे, किस चीज को आप सुपर सिस्टम में मानोगे, दैट विल डिपेंड ऑन द प्रॉब्लम दैट यू आर सॉल्विंग एंड द स्कोप in which you are able to operate. Suppose I was making this water bottle for a small child. Now, अभी मैंने जब प्राची के लिए कहा स्पिलिंग फंक्शन, तो आपको लगा कहाँ, ये तो इससे थोड़ा ना गिरेगा. But now I have put the term small child. Now do you realize that for a water bottle meant for small child, child is a part of the system. Is that okay? Building a super system? Okay. In दोनों problems के लिए, whether the bottle is not able to maintain the temperature of the water or that water क्या कहते हैं, does not directly go into Prachi's mouth, whether this is happening inside the building or outside the building, doesn't change, na?
Which the system interacts.
So he is saying anything with which the system interacts is super system. Yes, you can say that. Now, confusing? Confusing enough, at least, huh? So, clearly, you cannot do function analysis without first identifying what are the components of the engineering system and its super system. Are you able to see this? जब तक आपने components ही नहीं identify करे, can you analyze the problem? So the first step is component analysis. Okay. Then, once you have identified the components, you need to see how are they interacting amongst each other. Do they even interact? See, it may happen that there is someone standing outside of this room. They're not even able to hear what I'm telling. Then whatever I discuss in the class, can that person claim that I was the cause of that distress that was caused to him? Suppose मैं यहाँ पे आपके अर्पित कोई बुरी तरह लताड़ रहा था, ये कह रहा है सर कि आप फर्स्ट सीट पे बैठे तो आप मेरा एग्जाम्पल बनाते रहते हो. सपोज मैं इसको यहाँ बुरी तरह लताड़ रहा हूँ, आप सब लोग यहाँ बैठे हो, आप लोग मेरी आवाज सुन पा रहे हो, मेरे को देख पा रहे हो, उसको भी रोते हुए देख पा रहे हो. नहीं सर मैं रोता नहीं हूँ, नहीं रो रहा है, ठीक है. तो आप पे एक इम्पैक्ट आ रहा है. There is some interaction happening with you. There is someone in the other classroom. We are sure the sound is not going out. We are sure they are not able to see it. Can they claim that because I was scolding Arpit, that person is getting tensed? Now, if you talk about visual field and auditory field, no. Now he says, oh, he is emotional. No, she is emotionally connected with Arpit. तो अर्पित यहाँ रो रहा है, उसके दिल में वहां पे धक 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 हो रहा है. On that field we can't see, so we can't say. We will not mark that in the engineering system. But interaction analysis is the next step. Because if someone is not even involved, we may say that putting that as a component in my matrix and my component analysis is also not worth it. See, otherwise I can, and for this class, if I was to make a functional analysis, I could put the entire institute as a part of the super system. Is it not? All your other courses, everything else, I can put as a part of the super system. They are a part of the super system. But if I start to analyze everything, problem solve nahi hogi. Why are we here? We are here to solve problems, is it not? The courses, creativity, innovation, and inventive problem solving. We want to solve problems. As engineers, good engineers solve problems elegantly, lazy way. But do you realize lazy doesn't come easy? It requires you to sit with the problem in a very structured and disciplined manner. Otherwise, you will not be able to identify those key disadvantages, for example. So, second step is interaction analysis. And third step is function modeling, where we finally put all the systems together and say, okay, look at the superheroes game. If I do the interaction analysis there, I interacted with only the leaders, then the leaders interacted with you. Now, if I have to make a function model, I would say Anuj interacted with A, B, C, D, E, nine teams we had made, 9 people. And then those 9 people each interacted with their 5 people. Did Anuj directly interact with the last person? No. In the function model, if this central person made a mistake, all those 9 people will be impacted. But the remaining, all those 5 people will be impacted, but the remaining 8 teams will be fine. So function model is about clarifying who is interacting with what, in which way, so that now when I know there is a problem, I can use this function model to analyze the system and arrive at disadvantages and key disadvantages faster. See, abhi tak, for some of you, you are working on hypothetical problems, real problems, but you did not have a function model with you. So you are getting stuck with ये y कहाँ से निकालूं? अब इसका y क्या है? कैसे पता लगेगा? Now, what we are going to do will help you identify what is the answer to that y now. Are you able to see this? So, function model, again, अभी आपको CEC, cause effect chain analysis से ही कितना clarity आया? ये आप तब आया clarity जब आप अभी भी मेरे से पूछोगे सर यहाँ अटक गए, what to do? For many places, many of you, how many of you in your team said that, oh, now what do I do? Even though there is far more clarity, you're still not sure what to do. A function model is there to help us with that. Is that okay? So, how do we do the component analysis? Very simple. Component analysis is used to identify the components of an engineering system. Now, read the term. Relevant components are identified for the engineering system. Relevant components. Relevant. वही जो हमने कहा ना, सुपर सिस्टम में इतना सब कुछ है. I don't want to cover everything. Relevant ones. Are you with me? So, for example, when I talk of a drone would have its chassis, it would have some sets of nuts, some sets of wires, capacitor, power supply, propeller ke wings, remote control, and so many things. All of these ensure that a drone system works. Now, if that drone system was to carry a delivery packet, Naman, so that now this load is also a part of the engineering system. Are you able to see this? वो सारे components हैं, but ये load भी अब engineering system का part है. Because that may change the entire properties of the drone.
So, the example we mentioned
For bottle.
what becomes the part of the system?
Water, yes.
Similarly, rain will be also a part of the system. Rain will also be a part of.
Can be. Clouds, wind, everything, air. Of the system that you will evaluate. It is a part of super system or system. See, can you control the air? No, it is super system. But it is important to be a part of your component analysis because it is relevant to your problem. Water over here is not a part of the bottle, but it is an important part of my super system. उसी का तो temperature maintain करना था. Now, if water spill हो रहा है for a child, then water is actually a part of the system itself because वही तो spill हो रहा है. Are you with me? So, components can be substances which are objects with a rest mass. Or components can also be fields which are objects without rest mass but transfer interaction between substances. So in this system, the magnet, the iron filings, and the magnetic field all are components. Are you able to see this? So even fields, जैसे मैंने कहा कि इसके दिल में कुछ हो रहा है, किसी और को पता लग रहा है. अगर हम कंपोनेंट एनालिसिस करेंगे तो हमें वो वाला फील्ड पता लग जाना चाहिए. देखा नहीं सर, ऐसी कोई नहीं है. You get that? So, component analysis is done in steps. First is create a hierarchy of components. Then select a hierarchical level. We'll just see, ये भी नहीं समझ में आ रहा होगा, we'll see an example how to understand this. And then identify the components at that level of hierarchy. For example, when I talk of this bottle, I could say that the hierarchy includes the cap, the body, and the water. Or I could say that the hierarchy includes this rubber string, rubber walls, whichever way you want to call it, this plastic insert. It includes the extra layer that I have put inside this enclosure, etc., etc., etc. If there were nuts and bolts, I could say nuts and bolts also. Hierarchy has changed. This was one level of hierarchy, which was easily, and a user can see that different components exist. Another level of hierarchy is where an engineer who assembled this bottle would be able to see. Another level of hierarchy is atoms and molecules and whatnot. Are you able to see this? Now, the important thing is when you do component analysis, you should stay at one hierarchy level only. Don't mix two hierarchy levels. Okay, let's look at an example. Car. Okay, so second level पे electrical system है, steering system है, and fuel system है. Let's go in deeper into, let us say, electrical system. So I have alternator, I have voltage regulator, and I have battery. Let us go deeper into battery. Electrodes, electrolyte, casing. Now, whichever problem you are trying to solve, you have to choose a hierarchical level where all the relevant components are available to you. Suppose you wanted to to handle the problem of improving the efficiency of charging of the battery, and you pick up this level. Now the problem actually completely exists within the electrical system itself, and there's nothing that you can talk about. Does the steering wheel has anything to do with charging a battery? No. Aapka function model bekar hai. It doesn't handle the problem that I wanted to solve. Are you with me? Now, let us say you chose this one. Okay, alternator charges the battery. Voltage regulator also has some play with the battery. The battery is there. This seems like a okay level. Let us say we chose this one. Now, unless you are a chemical engineer who knows how to handle or whose job responsibility is to choose the right electrolyte and the right electrodes, if you make a function model here, again, doesn't work for you. Are you able to see this? So you cannot be very deep down. You cannot be very deep, very high up. You have to be at the level where various components are something that you can do something with. The problem is not limited in only one small thing. See, battery charge nahi ho rahi hai time se. So all this is important, is it not? Now for a battery manufacturer, this is the level they will operate at. But for a mobile phone manufacturer, forget car, mobile phone manufacturer, this is the level they will operate at. Are you able to see this? Apple will tell their battery people that if my charging happens at this particular rate, the battery should not blow up. So choose the material such that battery doesn't blow up when I charge it to that level. But that problem is being solved by battery manufacturer. Apple in its office is solving the problem of how do I ensure that this battery, whatever the size is, gets charged within 30 minutes. Are you able to see this? This is a very valid level for someone to operate. This is also a very valid level for someone to operate. Something else, this is also a very valid level. Are you able to see this? So choose the hierarchy of components very carefully. Are you with me? Clear है यहाँ तक? Any questions? So you have to select the level based on project goals and constraints. Select components at the same hierarchical level. Many times you may be able to consider similar components as one component. For example, you may say nuts. You are modeling this table, you will say these many nuts and bolts are put there. Simply say nuts hold the frame together. However, there will be cases when you may want to say 6 nuts. 2 nuts holding the top, 3 nuts holding the bottom, and then 1 nut holding somewhere else. When is this definition of 6 important? For example, if I know that the problem is with the base only, or I do not know where the problem is, but I know that one of my targets is reducing the overhead of assembling the table. I know the more the components, the more is the overhead, more cost of assembling. So I somehow have to reduce. So I will now keep the count. Otherwise, if that is not the problem, I'm only talking about, for example, how to decorate this table, how to make it more pleasing to look at, then nuts is a good enough component to talk about. Are you able to see this? Again, the context of the problem defines which detailing I will go into. Are you able to see this? And if a component requires more thorough analysis, go to the lower level of hierarchy. कि अगर आपको दिख रहा है कि यार इधर तो सब कुछ ठीक ही चल रहा था. फॉर एग्जाम्पल किसी ने अगर ऊपर वो क्या कहते हैं इलेक्ट्रिकल सिस्टम, स्टीयरिंग सिस्टम और वो वाला लेवल उठा लिया था, तब उसको कैसे दिखेगा कि बैटरी क्यों नहीं चार्ज हो रही? They're not able to see the problem also. They just know the problem, but they're not able to map it. It usually says go deeper down. Or basically change the level of hierarchy. Is that okay? Clear? Let's look at an example. So, this is a paint filling system. So what is the paint filling system about? It's a plant in Russia. Altschiller was from Russia. So उसी का दिया हुआ example है. हम सब टोप रहे हैं उसको बेशर्मों की तरह. But it's a very powerful example because it explains function modeling very, very easily. We'll use this example throughout. So be extremely alert, Abhi. You should understand what we are talking about. So this is a factory which manufactures radiators. Radiators पता है आपको? How many of you have opened the hood of a car? So there is this radiator which cools the engine. उसके अंदर से coolant move करता है और वो that kind of dissipates the heat. So radiators are a very, very key component of a car. And now this factory manufactures radiators. And these radiators have to be painted because iron के हैं. अगर paint नहीं करोगे तो rust लग जाएगा. You want long life, so you have to paint them. So what happens is it's like an assembly line. इस उधर से कहीं से radiators forge होके पीट पिटा के आते हैं. And यहाँ पे पेंटिंग का एक टैंक है. पेंट से फिल्ड एक टैंक है. इधर आते हैं, यहाँ पे डिप करते हैं और डिप करने के बाद वापस ऊपर चले जाते हैं. सो इट जस्ट यू सी कितने सारे रेडिएटर्स एक साथ पेंट होते जाएंगे. हाँ, बट देयर इज अ प्रॉब्लम. सो ये छत पे जाके किसने अपने हॉस्टल या घर की टैंकी में फ्लोट देखा है? देयर इज दिस फ्लोट दैट इज देयर, जो जब पानी भर जाता है टैंक में तो फ्लोट ऊपर हो जाता है एंड it stops water from entering in. You seen that? So they use a very simple float over here also. Now the float is called a float because it is expected to, it is very light and it is expected to float. But with paint, something happens. With paint, what is happening is paint solidifies on the float. आपने देखा? खाना भी खाते हैं तो चीज चिपक जाती है थाली के साथ. जिस कटोरी में आपने दाल खाई वहां पे हल्का सा. सो धीरे धीरे करके a lot of paint solidifies on the float. So what happens? The weight of the float increases. तो जहां उसको ऊपर उठना चाहिए था, now the paint doesn't lift it. So the pump continues to pump more paint in tank, and tank overflows. Now imagine you are on a shaft floor. This system was running overnight. In the morning you come and the entire shaft floor is yellow. And it is continuing to go yellow and yellow and yellow because more paint is getting pumped and it is overflowing. Now what do? You somehow switch off. पहले अपने जूते खराब करोगे, उसको switch off करोगे मशीन को. वहां पे रेडिएटर्स वाली मशीन को बोलोगे रुक जा भाई तू मत भेज, और तो वहां पे पाइल अप होना शुरू हो जाएगा. अब यहाँ पे पूरा साफ करोगे, फ्लोट को चेंज करोगे. एटलीस्ट 24 to 48 hours gone. And then automotive manufacturing, this was not acceptable. Come to think of it, आपकी कार आके खड़ी हुई है, आती जा रही है कार्स, और उनके अंदर रेडिएटर ही नहीं है लगाने को, बिकॉज वहां पे रेडिएटर की फैक्ट्री 2 दिन से बंद पड़ी है. उन कार्स को कहां खड़ा करोगे भाई? See, they're not fully made cars yet. पूरा एक असेंबली लाइन है, रेडिएटर अपना आता है, अंदर लग जाता है, सब कुछ ऑटोमेटेड है. अब रेडिएटर है ही नहीं. This car stopped, every car stopped, the entire car manufacturing unit is halted. Just a small float, air solidifying on the float. Thousands of dollars of losses. Are you able to see this? The key disadvantage is air and float and paint. अभी नहीं आता की disadvantage पे. अभी हम component analysis करते हैं. So let us set out to do the component analysis of this system. Is it okay? So यहाँ पे यही problems explain करी गई है कि जब फ्लोट ऊपर जाता है तो वो इस स्विच को ऑफ करता है, स्विच ऑफ होता है तो वहां पे पंप बंद हो जाता है, पंप बंद होता है तो पेंट फिल होना बंद हो जाता है. जब पेंट का लेवल वापस कम जाता है तो फिर फ्लोट ऑन हो जाता है. जस्ट एक्सप्लेनिंग दैट प्रॉब्लम. ऑल ऑफ यू आर स्टूडेंट्स ऑफ इंजीनियरिंग, तो आपको इस तरह के लूप्स को समझना तो आता ही है. Am I right? So they want a solution, but the solution should not have complex approaches such as sensors, because of the high cost and maintenance. Okay, we want a simple solution to the problem. And something really needs to be done. Is the problem clear? Because until the problem is clear, हम आगे जो भी बात करेंगे उसका मजा नहीं आएगा. So this is our paint filling system. It has barrel, pump, motor, part, paint, tank, float, switch, lever, everything. And this is how we do its component analysis. We say float, lever, switch, motor, pump, and barrel. They are all parts of the system. But paint, tank, parts, air, gravity are super system components. Are you able to see this? So जब यहाँ बात कर रहे थे पानी, in this case because it is about paint, या जैसे अगर हम पानी को ठंडा रखने की बात कर रहे होते, so water is a super system component. जो भी आपका टारगेट है, target means something on which you want some solution, that will always be a part of the super system. That cannot be a part of the problem. That cannot be a part of the system itself. Are you with me? Is it clear? So target means system. Why does the system exist? To do something. The bottle exists to hold water at a temperature and maintain its temperature. That is why. So water is the target. Water is a part of super system. Is it okay? So कितनों ने notes बनाए हैं इस function analysis, component analysis के अभी तक? How many of you have made notes about component analysis? तो बाकी लोग क्या करेंगे? See, not good. You should be active. So, जिन्होंने notes नहीं भी बनाए चाहे बनाए हैं, is the component analysis clear until now? I would want you to review. We will go deeper into component analysis and then go further into function analysis in the next class. Is that okay? Chalo. Thank you. All the best, guys.